Hello Math 7 students, this is Utah Middle School Math Project 4.1a class activity. This is part 2. In our last video, we talked about what a ratio is. Remember that a ratio is a comparison of two or more quantities. Not often will we be comparing more than two, but sometimes we will. We saw in our last video that we have a couple of different models to use. This is what we call a tape or a bar model. We also made a double number line diagram. Those are both models that can be really helpful in these ratio problems, but even more helpful than that is showing your work like this. This is another model, and it is my preferred way of doing it. If the double number line helps you, you can always go back to the double number line. If the tape or bar model helps you, you can always go back to that as well. For the most part, when I'm showing work, I'm going to be showing it like this instead of drawing out those models. You might remember from last time that we were asked to write ratios as fractions. Back in 6th grade, we would write ratios like this, where we'd use that little colon. Now, we're sophisticated middle schoolers, so we write our ratios with a fraction. Now, there is a difference, and I do want you to add to your notes now. Although this looks like a fraction, it's not officially a fraction. Make sure you're adding to your notes. Whenever I'm writing, you should be writing too. It looks like a fraction, but it is not officially a fraction. The clues that remind us that it's not officially a fraction are the fact that we are using units. It's not just 2 over 6 or 2/6. It's 2s over 6r, where the S stands for sunflowers and the R stands for roses. This reminds us that although it looks like a fraction, it's not officially a fraction. The next thing that I want to talk about and review from our last video is this part right here. We can see that this whole entire bouquet is made up of sunflowers and roses. Another way that we can say this whole bouquet is part sunflower and part rose. This leads very nicely into what we're going to be talking about next. And that is down here, part to part versus part to whole ratios. Now we're ready to talk about part to part versus part to whole ratios. And to explain this, it's best explained with an example. We're going to stick to the same example that we've already been dealing with. And that is we have a whole entire bouquet, and that bouquet is made up of sunflowers. That's part of the bouquet. And the other part of the bouquet is roses. So we have 2 sunflowers, 2 6 roses. In other words, we have part of the bouquet to the other part of the bouquet. To really understand this, let's talk about part to whole. Part to whole is talking about parts as it relates to the whole entire thing. So let's think about this. We'll go back to that image. If I have 2 sunflowers and 6 roses, how many total flowers do I have? 2 sunflowers and 6 roses. How many total sunflowers do I have? Should be a few more hands than this, like a lot more hands than this actually. 2 sunflowers, 6 roses. How many total flowers? Thank you, Berkeley. It would be 8. How did you get that? How did you get the number 8? Can someone help her out? How did you get the number 8? Stephen? 6 plus 2 is 8. So we simply add the 2 parts together, part sunflower, part roses, add them together, and that gives us the whole amount. And so let's finish up that example here to really understand part to whole. This is like 2 sunflowers, but instead of this time comparing it to the 6 roses, I'm going to compare it to the whole 8 flowers in the bouquet. 8 flowers in the whole bouquet. Again, this means I've got the part to the whole amount. How did I find that whole amount? We added up the part and the other parts, add that up together, and that's how I get the total or the whole amount of 8. Now, there is another part to whole ratio that I can do. Think about that for a second. I have this part to part, 2 sunflowers to 6 roses. I have this part to whole, 2 sunflowers to 8 total flowers. What is the other ratio that I could do? Talk amongst your group members first. There should be some discussion going on right now. What is the missing ratio? Okay, now you've had a chance to check in with your group. So let's see the hands. What is the missing ratio? Good. Let's go with Miley. You're close. Not 6 whole flowers, 6 what? 6 roses. Yes, instead of using the 2 sunflowers, we're going to use the other part, which is 6 roses. 6 roses to what? 6 roses to, Chandon? The 8 flowers in the whole bouquet. Again, this is the other part this time, but it is the other part still compared to the whole. And again, I find that whole by adding up the part and the other part. Now we've explained it with an example, and I do feel like this example really does a good job of defining it, helps us understand it, but I want to actually put it in words. So I know you might be getting a little bit tight on space. You might not have too much left, but see if you can squeeze this in. It's only one sentence. A part-to-part ratio is a ratio that compares parts of a whole to different parts of a whole. Again, sunflowers were part, the roses were the other part, so we're comparing parts with parts. And so what I would write here on the part to whole this is a ratio that compares parts of a whole to the total. The total is also known as that whole amount. Great to include this vocabulary. I appreciate all the students who are writing this down with me. I am going to be going to a new screen in just a second, so please finish writing. Online learners who need any extra time, you can always pause the video at any time to give you that extra time. Okay, I want pencils down because this next part is really important and I want to make sure that you're really listening and paying attention. So pencils down, stop writing, eyes on the screen. We talked at the beginning about how, even though the directions say write them as fractions, and we said This is a ratio that we used to write in 6th grade, and now we write it so it looks like a fraction, but I warned you, this is not officially a fraction because it's a part-to-part ratio. However, when I have part-to-whole ratios, these are fractions because it's a part compared to the whole. Write that part down. Now you can pick up your pencil now that you listen to that. Write that down. Part to whole, these are fractions. They're officially fractions. Because fractions compare parts to the whole amount. All right, let's move on to some examples to practice. The first one, I am going to walk through it with you. I'm going to ask you to raise your hand, activate your brains, help contribute, and then the next one I'm going to let you guys work on your own. So we should all be done taking notes here, and we're moving on to the next page. The directions say use a model. Let's first stop and make sure we understand what it means by use a model. As I mentioned earlier, one model that we can use is a double number line. Who likes the double number line and might probably use that for their problems? Good, a few of you. Double number line. Another model is the tape diagram. How many of you guys like this and will probably draw tape diagrams? Okay, good. I, however, will not be using those models. I am just going to show the calculations. So that's your final option, is just show the calculations. Okay, so when I'm showing work, I'm going to show the calculations. If you like the double number line or the tape diagram, you can do it that way. This first one, let's work through it together. It says, the high school has a new ski club this year. In the club, there are 4 girls and 16 boys. I'm going to stop before we even move any further. Here's a question that I want you to consider for this problem and all the others. Is this a part-to-part? Or is this a part-to-whole ratio? Quiet think time. No talking at your tables. Just think, is this part-to-part? Or is this part-to-whole? Now let's take a vote. Hands down, all the hands down. Who says I think it is a part-to-part ratio? Hands up. Okay, hands down. Who thinks it is a part-to-whole ratio? All right, a few of you. Let's go with the majority first. Why do you think it's a part-to-part ratio? What do you think, Chandon? Okay, that's a good thought, that they would give us the information for the whole entire thing, not just a part. Trinity, last comment. Good. And I'm just going to repeat what she said for the video. I need to practice doing that a little bit better. It gave us girls and it gave us boys. Did it give us the total number of people in the club? No, it gave us a part of the club, girls, and it gave us the other part of the club, boys. So this is actually a part-to-part ratio. Okay, now let's actually do this. Again, it says use a model. My model that I'm going to do is just showing my calculations. Use a model to find the simplest ratio of girls to boys in the ski club. So I'm going to start by writing that like a fraction. And I'm not just writing the number 4, and I'm not just writing the number 16. I'm writing 4G for girls and 16B for boys. And again, I'm color coding here. You guys can use any colors you want. I'm just picking 2 colors and I'm going to kind of underline or highlight those same things that represent that same information in that same color. So for girls, I did that in the same color when I wrote it down. 16 boys, and then I wrote it in the same color. And we're looking for the simplest ratio. Now in our last video, when we looked for the simplest ratio, I asked the question, is there a number that I can divide both 4 and 16 by? Think about that. Is there a number that I can divide 4 by and that I can divide 16 by? Have a few hands going up. Activate those brains. What is that number? Jessica. What is it? Yes, it is 4. I'm very impressed. A lot of students don't see that it's 4. They have to go baby step it and say that it's 2. You're absolutely right that it's 4. Let's do that in one step then. 4 can be divided by 4. And 16 can also be divided by 4. 4 divided by 4 is equal to 1, but I'm not just writing 1, I'm writing 1g. And 16 divided by 4 is equal to 4, but I'm not just writing 4, I'm writing 4b. This is the simplest ratio, because if I ask that question again, is there a number that both 1 and 4 can be divided by? The only answer would be 1. And if I divide by 1, is that really doing anything? 1 divided by 1 is still 1, and 4 divided by 1 is still 4. So there's no sense in dividing by 1 if it's not going to simplify it. So we did find the simplest ratio. Notice that I put a box around my answer. Great habit to get into, put a box around the answer. Next problem, it says, if there are 2 girls, how many boys are there? So I'm going to start with that original ratio, 4g to 16b. And the question is, well, what if there's 2 girls? So I see that 2 girls, which means I'm going to be doing it in the same color if I'm color coding. And I have 2g. How does the 4 change to a 2? Good, I love the number of hands. Not every hand is up though, so quickly turn and talk to your neighbor. How does a 4 change to a 2? How does the 4 change to a 2? Let's see those hands now. What would I be doing, Emma? Love that, tying into last unit. We can divide by 2. We can also multiply by 1 over 2 or 1/2. Love making that connection. Let's just, for making it nice and simple, let's divide by 2. So since I'm dividing this by 2, that means I probably should take that bottom number and also divide it by 2. 16 divided by 2 is equal to 8. Not just 8, but 8 boys. Now, think about our math practices. This is a very abstract answer. It means 2 girls for every 8 boys. But this is abstract. Let's write what it actually means. This is abstract. Let's make it quantitative. 2 girls would mean there are 8 boys. Now we made our abstract answer quantitative. We gave it meaning in the real world. And now it says, use a model to find another equivalent ratio. Remember our different models. We can do a double number line. We can do a tape diagram. We can just show our calculations. For the sake of time, even if you prefer one of these other ones, since we haven't already made it yet, I think that just showing our calculations would probably be best. So I'll get you started. 4g to 16b. Find another equivalent ratio. Find 2 of them, actually. Work with your groups. I'm going to wander. Online learners, you're going to pause the video while you find 2 equivalent ratios, and then we'll come back and check in together. Pause the video now. Okay, who has an equivalent ratio? Gavin. Good. 400. 400 what's? Good. 400 girls, so I'm going to remember the G. And you said 1,600. 1,600 what? B for boys. Good. How did you get there? How did you change this 4 into a 400? Good. We multiplied by 100. 4 times 100 is 400. 16 times 100 is 1,600. Love that. Very outside of the box. A lot of times kids just try and just multiply by 2 or 3 or something small. Love thinking outside of the box. Give me another one, please. An equivalent ratio to 4G and 16B. 4 girls, 16 boys. What did you come up with, CJ? $16 girls and 64 boys. And how did you get 16 girls and 64 boys? Multiplied by 4. Is it okay if other students multiplied by something different? Yeah, these are just examples. But the key thing is whatever we do to one, we do to the other. And the other key thing is multiply. Divide is also okay because we divided in our other examples, but do not try and add or subtract. It's not going to work out for you. Last question here before I set you free to work on the next problem on your own. In the drama club, there are 3 girls and 14 boys. Is this the same as the ski club? Look at the ratio of girls to boys in the drama club, compare it to what we've been looking at, girls to boys in the ski club. Are they the same? Again, work with your groups. Quick discussion. Online learners, pause the video, answer that question. Is this the same ratio? All right, let's take a quick vote now that we're back. Raise your hand if you say yes, they are equivalent ratios. Same ratio. Okay, and hands down, raise your hand if you say no, they are not. All right, let's go with the majority then. Let's explain this. Now, I'm going to ask some questions instead of having you guys explain. Go ahead and put your hands down. I'm going to ask some questions. Can you very easily turn a 4 into a 3? No. How? If you say yes, tell me how. How? No. 4 times what is 3? Not an easy question to answer, is it? And since it's not an easy question to answer, let's not answer it. Let's use our simplified ratio. Our simplified ratio, we already took the 4 girls and 16 boys and simplified it to 1 girl and 4 boys. We did that by dividing, right? And so now, isn't this a much easier question to answer? How does a 1 change to a 3? Multiply by 3. So we should take the 4 and multiply it by 3. And 4 times 3 is 12. What is it supposed to be according to this? 14. But it's not. It's 12. So are they equivalent? No. It should be 12. But it's actually 14. So are these equal? No, they are not. And now, ladies and gentlemen, I need you to go through parts 2A and 2B with your groups. Part C, scribble it out. I do not want that on there. I should have deleted it, so I apologize for that. You're not answering C. You're just answering A and B. Again, it says use a model. You can use any model you want. I'm going to show my work using a certain model, but you guys can use a double number line or a tape diagram. Work with your groups, answer parts A and B. Online learners, pause the video and answer parts A and B. All right, so we have 3 black cats. Notice I'm not just writing 3, I'm writing 3B for black cats. And we're comparing that to our 6 striped cats, so I'm not just writing 6, I'm writing 6S for striped cats. Looking for that simplest ratio means I'm asking the question, what do 3 and 6 have in common? What number can I use to divide both 3 and 6? Hopefully you have recognized that I can divide 3 by 3 and I can divide 6 by 3. So 3 divided by 3 and 6 divided by 3. Again, look at how I'm showing my work. You can use a tape diagram if you like. You can use a double number line if you like. My preference is to use just the calculations and showing that work. 3B divided by 3 is 1B, 1 black cat. 6S divided by 3 is 2S, or 2 striped cats. So this is the simplest ratio. I'm going to go ahead and put a box around my answer. Part B says write 3 equivalent ratios. How do you know they are equivalent? So again, I'm going to start with my original. My 3 black cats, my 6 striped cats. Equivalent ratios. You can do any number of things. You could divide if you wanted to, but we already divided by 3 and we got that. So really, we're probably better off to just multiply. What's your favorite number? Multiply by that. Maybe you want to multiply by 7. You can multiply by any number as long as you do the same thing to the bottom. 3 black cats times 7 would be 21 black cats. And 6 striped cats multiplied by 7 would be 42 striped cats. There is one equivalent ratio. Another equivalent ratio, again, you can choose any number you want to multiply. This time, maybe I'll go with a lot smaller number and just multiply by 2. 6 times 2 is going to be 12 striped cats. And since I multiplied the bottom by 2, I'm going to make sure that I multiply the top by 2 as well. 3 times 2 is equal to 6 black cats. So again, here are two equivalent ratios. It asks, how do you know they are equivalent? And I showed all of my work. That's a great way to answer that question of how I know they're equivalent. That is Math Practice 3, constructing viable arguments. I showed that 6 times 7 is 42 and 3 times 7 is 21. That's how I know they're equivalent. That's it for today. We didn't finish the lesson, so we're going to continue this one more day. But this is it for now. Have a good one, and we'll see you next time.